Welcome to today's lesson in physics, that is acceleration. In previous lesson we discussed differentiation. Hope you are following that. Okay, so in acceleration also we need that. So these days I'm giving only small videos. You focus on that differentiation and be thorough with it. Okay. Now let's come to the point, that is acceleration. It is the rate of change of velocity with respect to time that you have already studied in ninth standard. What do you mean by acceleration? Rate of change of velocity with time. As we studied average velocity and instantaneous velocity, here we can define average acceleration and instantaneous acceleration. So what will be average acceleration? Average acceleration will be the acceleration over a time interval. As we said, if at time t1, v1 is the velocity and at time t2, v2 is the velocity, then average acceleration is given by v2 minus v1 by t2 minus t1 is equal to delta v by delta t. So here, what about v1 and v2? v1 and v2 are the instantaneous velocities. v1 and v2 are the instantaneous velocities at time t1 and t2. Okay, so actually this is the expression for average acceleration. So average acceleration is the change in velocity by time interval over an interval of time. And what will be the SI unit of acceleration? It will be meter per second square. So what will be the instantaneous acceleration? So instantaneous acceleration is the same way as we define instantaneous velocity. So what is it? Limit delta t tends to 0, delta v by delta t. Okay, so average acceleration under the condition delta t tends to 0 becomes instantaneous acceleration. That way we defined instantaneous velocity, no. Average velocity under the limiting condition delta t tends to 0. So here average acceleration under the condition, limiting condition, that is delta t tends to 0, delta v by delta t is what? This instantaneous acceleration, and it is nothing but dv by dt or d by dt of v. What is v there? Velocity, where velocity is a function of time. Okay, so that is how we can define instantaneous acceleration. So average acceleration is what? Delta v by delta t, and instantaneous acceleration is dv by dt. Okay, now we can find average acceleration and instantaneous acceleration from graph. Which graph? Velocity time graph. So if you have velocity time graph, the slope of velocity time graph, if this velocity time graph is a straight line, the slope of the velocity time graph will give you acceleration. If the velocity time graph is not a straight line, to find instantaneous velocity at a particular instant of time, at that particular instant of time you can draw a tangent to that graph and find to the slope of that tangent. So slope of tangent to the VT graph will give you the instantaneous acceleration. Speaking about acceleration, so acceleration is the rate of change of velocity with respect to time. Okay, so this acceleration, change in velocity, means velocity is a vector quantity. It has got both magnitude and direction. So this acceleration may result from a change in magnitude of velocity. Magnitude of velocity we call that speed. So due to a change in speed, or due to a change in direction, or change in both, may result in an acceleration. So when we speak about acceleration, in what all ways we will say the body is under accelerated motion? When a body has a change in speed, increase in speed or decrease in speed, or when a body changes its direction, or when a body undergoes a change in both, that means change in speed and change in direction, we say that the body is under accelerated motion or body is having an acceleration. Okay, so this acceleration can be due to these three reasons. Then this acceleration, being a vector quantity, can be positive, negative or zero. So acceleration can be positive, negative or zero. So how the positive acceleration, negative acceleration and zero acceleration? Zero acceleration means what? When acceleration is zero means delta V is zero, because simply with the what is acceleration? Delta V by delta T. So if acceleration is zero means delta V is zero, means there is no change in velocity. No change in velocity means what? Velocity is a constant. If velocity is constant means what type of motion it is? Uniform motion. So for a body in uniform motion, it will not have any acceleration. So for a body in uniform motion, its acceleration will be equal to zero. So acceleration zero corresponds to which type of motion? Uniform motion. Now this shows different graphs. That means I said acceleration can be positive, negative or zero. So how the position time graphs of these objects will be? That means when acceleration is positive, negative and zero, that is what is shown in the diagram. So when acceleration is non-zero, that means if it is not equal to zero, that type of motion will be non-uniform motion. We have already discussed non-uniform motion. Non-uniform motion means it is the body is undergoing changes in velocity, not unequal changes in velocity or speed in equal intervals of time. Velocity or speed changes through unequal values in equal intervals of time. That's what we mean by non-uniform motion. So for a body in non-uniform motion, generally I am telling the acceleration, if it is positive and negative, the graph will be a curved graph. Okay, that curved graph is as shown, positive acceleration and negative acceleration. For positive acceleration, it is curved upwards, and for negative acceleration, the graph is curved inwards. And for zero acceleration, you know that graph, position time graph will be a straight line. Now let's discuss one problem. As we did earlier, that means in the previous class, the velocity of a particle is given by the equation v is equal to 2t square plus 5 centimeter per second. So instead of meter per second, it's given in centimeter per second. Find the change in velocity of the particle during the time interval between t1 equal to 2 seconds to t2 equal to 4 seconds. So you're asked to find change in velocity. Second, what you have to find? Average acceleration during the same interval and the instantaneous acceleration at t2 equal to 4 seconds. So in short, you have to find average acceleration for a time interval and instantaneous acceleration at t2 equal to 4 seconds. So what it is given is v. So if v is given, how can you find? Let's start with instantaneous acceleration first. That is easy, no? What is instantaneous acceleration? A is equal to dv by dt or d by dt of v. So by doing that, you will get, so instantaneous acceleration A equal to dv by dt, that is d by dt of v. What is v? 2t square plus 5. Now you perform differentiation. You will get it as d by dt of 2t square is 4t. Then d by dt of 5 is 0. So A acceleration, you will get it as 4t. Then at t equal to 4 second, what is acceleration? 4 into 4, 16 centimeter per second square. Okay. Now coming to average acceleration. What is average acceleration? v2 minus v1 by t2 minus t1. So first of all, you should find v2 and v1. That means at t1 equal to 2 seconds, you have to calculate what is velocity. That will give you v1. So this equation you have to use. In that equation, put t equal to 2 second, you will get V1, that is 13. Then in the same equation, put T2, that is 4 second, you will get V2, that is 37 centimeter per second. Now, what is change in velocity? It is 24 centimeter per second, and change in time is 2 second. So you will get 24 by 2, that is 12 centimeter per second square. Okay, so this is how you can solve this question. So be thorough with differentiation. Again and again, the same questions which I gave you, you do for 2 days, you do it, repeat it. Then only it will come to you. The process of differentiation will be okay for you.